Now that we have nodes and OSDs, we can look at the crush map. So crush computes the locations to store and retrieve data. It's the technology that enables clients to read and write data directly on the drives themselves without any kind of centralized director like a traditional SAN. Crush is the secret sauce that makes Ceph decentralized. We can create fault isolation with failure domains by describing a hierarchy of how we desire our data to be distributed among the OSDs. This is done via two parts, the crush map and the crush rules. And in our GUI, we feature drag and drop configuration of the crush map. This drastically simplifies the steps to edit. This is also my favorite thing to demo. Being visual, it drastically reduces the errors with non-croit methods. This is done by downloading a compiled file, decompiling, editing the text file, recompiling, and pushing the new config. Um, this can be an error-prone process, and if you mess up, you are likely going to cause a lot of data movement. If that is left unfixed, this would eat performance because data movement is going to be eating up bandwidth and IOPS, and ultimately would need to be corrected, which would then eat up more bandwidth and eat more IOPS. So croit also evaluates the bucket type hierarchy, so you don't need to think about it. And let's show creating a bucket. So in this case, we have our root, we have our OSDs under each host itself. So let's pretend like we want to separate these into separate racks for some additional redundancy. So if we lose one rack, we haven't lost the entire cluster, we've just lost, in this case, one node. So we're going to create 4 new buckets as racks. And again, we can drag and drop. Just like that. We also have an opportunity to evaluate the crush map. The croit software will do that for you, but then also give you a opportunity to see the actual steps that are going to happen so that you can understand what's actually going on behind the scenes, step by step. Apply that. So some common options, common buckets are racks, PDUs, and for stretch clusters, data centers. So again, for example, if you lose a node, rack, or data center, you still have availability if your environment is designed to be able to handle that. Also in this GUI, we can reweight OSDs. So we can select an OSD. On edit, we can see the reweight here. Generally speaking, this isn't something that you would need to mess with unless you were trying to drain an OSD or you had mismatched size drives. You can also change the device class. Earlier you saw that croit automatically creates these for you unless you specifically give it a certain device class name. And we can also create crush rules. Actually, before I leave this menu, I want to point out the PGs that are assigned to the disks. So you can manage that. In general, the current recommendation is aiming for about 100 to 150 PGs per OSD. So this is an easy way to see if your OSDs are overloaded or if they're underloaded, and you can maybe get a little bit more performance out of them. We can create crush rules easily. Croit provides the most common rules. Crush rules define how Ceph client buckets selects the buckets in the primary OSD. Things like specifying a drive class, EC or replication, and specific buckets can be done with a crush rule. Crush rules can give extra awareness to distribute the data according to your specifications in complex scenarios. Rules are used by pools themselves, and again, we provide the most common rules out of the box. And that's it for the crush map.